You all are welcome to Guru Gedara educational program. Today you have grade 8 science lesson, that is lesson number 4, properties and matter. As this is somewhat long and new lesson, I am going to do this in 2 parts. So, this is the part 1 of your lesson. Today I have brought so many things for you. So, at the first I will take one of them. Right. This is a piece of chalk. You know, this is the chalk we use to write on our blackboards. Then if I say like this chalk has a mass. This chalk has a mass. Can you agree with me? Yes, this chalk has a mass. You know that. Then if I say this chalk requires a space. This chalk requires a space. Is it correct? Yes, definitely. This chalk requires a space to be here. So, such kind of things we known as the matter in the science. So, that is your first lesson today. So, shall we move to the screen now? Here you can see the definition of the matter. Things that require space and have a mass are known as matter. You can see the examples: water, ball, bulb, table, chair, magnet and air. So, do you have any doubt about this air? Does air has a mass? How can you do a practical for that? You can just take a empty balloon and you can take the weight of that balloon. Then you can fill it with the gas and you can check the weight of that balloon again. So, by the difference of two values, you can check there is a mass for a air. So, that is the thing. Now, you know what is a matter. Shall we see then what is an energy? Let us go to the screen now. Here you can see the definition of the energy. Things that do not occupy space and have no mass are considered as energy. You can see the examples like light energy, sound energy, heat energy, electricity like thing. So, you can see this definition is the opposite form of the matter. So, let us see go to a small activity now. Here you have been given list of words. You have asked to classify as matter and energy. Okay, shall we check one by one? First, light. So, light should goes to energy. Then sound. Sound should goes to energy. Then air. Air should be a matter. Air should be a matter. Then water. Water should be a matter again. Then the bulb. Here bulb, again it is a matter. Then the table, it is also again a matter. Then heat. Heat should be an energy. And finally, electricity again should be an energy, like this. Okay, shall we move to exercise now? Here, you have been asked to classify those things as matter and energy. Here, you have been given some set of words: light, sound, air, water, bulb, table, heat and electricity. Okay. Shall we see how to classify them? At the beginning, light. Light should be an energy. Then sound. Sound should be an energy too. Then air. Air should be a matter. Then water. Water again should be a matter. Then bulb. bulb should be a matter again. So, table also a matter. Then heat should be an energy. So, at last electricity also should be an energy. Now, you know how to classify that. Now, we can go to another topic that is a new thing for you. Here, the discontinuous nature of the matter or the particulate nature of the matter. So, this is a new thing. I will tell you what is this. Okay. This is a piece of chalk as we talked previously. So, actually this piece of chalk consists of so many chalk particles. You cannot see them in your naked eye, but still there are so many chalk particles within this chalk. So, among those chalk particles there are many gaps or spaces. So, that nature we can known as this discontinuous nature or particulate nature of the matter. Right. Shall we see the definition of this? Let us zoom onto the screen now. Here you can see the discontinuous nature of matter means the status matter exists as a collection of particles with the spaces among them is known as discontinuous nature or particulate nature of matter. Right. Then we can talk about the status of the matter. Actually, there are three types of this, that is solid, liquid and gas. So, can you see the solid? Here green color balls are the particles. So, see the arrangement of those particles. There you can see particles are closely bound to each other. They are completely packed. So, spaces among the particles are very less. So, that is the nature of particles in a solid. In the solid, particles cannot move here and there. They just vibrate while they are at the same position. So, that is the nature, that is the particulate nature of the solid matter. Then see the second diagram to liquid. Here you can see particles are loosely bound, not like in a solid. Can you see the spaces among the particles are somewhat higher than the solid. So, particles can move here and there. So, that is the particulate nature or behaving of the particles in a liquid. So, finally, you can see the gas. Here you can see the third diagram as the gas particles. Here the particles are freely moving here and there. So, spaces among the particles are very high. So, you can compare the nature of the particles in status of the matter like this. Now, you can understand how the particles arranged in those matter. Then, we are going to talk about a solid, right? Discontinuous nature of a solid. Can you see the particles are just doing their vibration while at their same positions. Here particles are closely packed and spaces among the particles are very less. I will tell you a nice example for this. Think that you are in your classroom. When you are in the classroom, you are like this, you behave like this. When your teacher in the classroom, but still your teacher can come to you because of these spaces, but you cannot move here and there. You have to be there, you are nicely arranged in your classroom. So, that is how particles are arranged in a solid matter. Right. Then shall we see how about a liquid? Can you see here? This is the discontinuous nature of a liquid. Here you can see particles are moving here and there. So, they are not bound each other very tightly. They are loosely bound, and you know that spaces among the particles are somewhat higher than a solid. So, that is the nature of a liquid matter. Okay. Then the third one, this is the discontinuous nature of the gas. Here you can see particles are freely moving. So, binding power among the particles are very less. So, can you see the spaces among the particles are very high. Okay. Shall we go to the activity now? For this activity, you need a watch glass like this. This is the watch glass, and you need some color ink. You can select any color ink. Here I am using this blue color ink. I am going to transfer some amount of blue ink to this watch glass like this. Then I have this chalk. Then I am going to dip this chalk like this in the watch glass. Now, can you see, if you clearly observe, you can see now you can see blue color is coming up through the chalk. So, as a science student, now you can explain this. How you can explain this? By using the word discontinuous nature, can you explain this? Yes, you have to tell this chalk consists of particles. So, among those particles there are many spaces. So, because of those spaces, this blue color ink can pass through. So, that is how you are going to explain that. So, this is an evidence for the discontinuous nature of a solid. I think you can understand that. So, in the screen also you can see the same activity. So, this activity confirms that solid matter is discontinuous in nature or particulate in nature. Then there is another close up for you. This is the same practical. Here you can see it very clearly. They have used brown color ink here. You can see the brown color is going up through the chalk. Now, you know this is because of the discontinuous nature of the solid. Here the solid is chalk. Then after 5 minutes it will be like this. Then after 10 minutes you can see it like this. Right. Now you can understand that. Okay. Let's move to another activity to check discontinuous nature of the solid. This is activity number 2. Here today we are not going to do that practical because you know gold is somewhat expensive chemical, but you have to know the theory behind that. So, I will explain what is this. So, have you heard when a gold ring get contact with mercury, that gold ring get damaged? Now, how you can explain this? Here you have to explain this like this. You have to say gold is a solid matter. It consists of so many gold particles. Among those gold particles there are so many gaps or spaces. So, because of those spaces, the mercury, you know mercury is so liquid. So, mercury can go through those spaces. So, ultimately the gold ring will get damaged. So, that is how you are going to explain such situation. So, keep in your mind this is another evidence or another practical to show the discontinuous nature of a solid. Right. Now, you know that. Then we can discuss discontinuous nature of a liquid. There are many practicals for that. Shall we move on to another practical like this? This is from your textbook activity again. Here you need a beaker like this. I have a beaker like this. Then I am going to transfer some amount of water to this beaker like this. Then here I have a chemical like this. The common name is condis, and you know that is chemically we know it as the potassium permanganate. Actually it is purple crystal. Now you know here I took water. Now you know water is a liquid matter. Here I have a purple color crystal. Now I am going to add a small amount of this purple color crystal to this water beaker. You have to see what happened there, right? Like this. Can you see what happened? There you can see the water beaker get colored from the purple color. So now how can you explain this? Now you can say this water is a liquid. So the liquid has so many particles. That means among those water particles there are so many spaces. So among those spaces that purple color can go through. That is what we call the discontinuous nature of a liquid. Here liquid is the water, right? I will show you another close up from this practical. Like this, you can do this experiment at your home even. You do not need any beakers like thing. You can just take a glassware at your home, then you can add some water, then you can find this chemical. I told you this is the condis. Under the commercial name condis you can buy it. So, the chemical is potassium permanganate here. You can add some small amount of condis or potassium permanganate to water. Keep in your mind, we are going to check the discontinuous nature of a liquid. Here the liquid is water. I think you can remember what is the meaning of discontinuous. So, because of the spaces among the water particles, that purple color can go through. So, that is a simple activity, but you have to explain it in science. Okay. Then another textbook activity for you, they have asked you to add a drop of color into a water. I think you know what happened when drop of color add to a water beaker, but here the thing is you have to explain it. Here you can add any desirable color of ink to water beaker. Then you know what happened, the water get colored with that used color. So, how you can explain that? Here you can say water is discontinuous in nature or particulate in nature. That is why the color or the ink color is spread throughout the beaker. So, those are the two activities that we are going to learn in this lesson for discontinuous nature of the liquid. Right. Now, you can move to the third one, the last one, how to check discontinuous nature of a gas. Here, I will explain you how to do that at the first. See, here I have two gas collecting jars, right. You have to take one jar like this and you have to fill one jar with the colorful gas. Colorful gas means there are so many colorful gases, nitrogen dioxide or bromine or chlorine or you can just fill it with the fume. Fume you can generate with the joss stick like thing, right? You can just need the colorful gas. Then you have to trap it with separating this like this. You can use a glass plate or something like that, right? Then you have to take another gas collecting jar like this and you have to invert it. You can invert it. Now you know in this jar you contain a colorful gas and this jar contain normal gas. So, we are going to keep it like this. This is the invert position. So, then we can remove this separating disc and like this. Then now you know this is a colorful gas, this is normal gas. By when doing this practical, you can see the color of the bottom jar coming to this upper jar. So, how can you explain that? Let us see a video clip for this, because here you know this is a closed environment at the moment. I am not going to produce that gas inside this room, but you can see a video here. Let us move on to the video now. Here you can see nitrogen dioxide gas in the jar. So, you can see another jar can kept like this. Then can you see nitrogen dioxide is a brown color gas. That brown color diffuses to the top jar. Instead of nitrogen dioxide, as I told, you can take any colorful gas like bromine, chlorine, like anything. So, here you can see those are the brown color particles, that is nitrogen dioxide. White color particles are normal air. You can see brown color particles go through that white color particles. That is because discontinuous nature of that gaseous material. That is because discontinuous nature of gaseous matter. Then there is another activity for this. You can see that video, a smell of a perfume diffuses across the air. You know this. So, how can you explain this? You know, because its particles have moved through air and entered our nose. So, this is another evidence or another practical for discontinuous nature of the gas. Let us see the third activity for this discontinuous nature of a gas. Here you can see the scent of the lighted joss stick spread throughout the air, because its particles have moved through air and entered our nose during the spreads of particles. So, this is another evidence for discontinuous or particulate nature in gas. So, those are the practicals we discussed today. Then we have another new topic, that is physical properties of the matter, right. Here you can see, now you know matter. Matter means solid, liquid and gas, like this. Here a stone, it is a solid, you know that. Then glass of water, it is a liquid, then gas. Here you know all the matter consists of particles. That may be a solid, a liquid or a gas. All the things are made up of particles. Then because of those particle arrangements, there are some particular properties. Now we are going to talk about those properties. Here the shape can be vary, mass can be vary and volume can be vary with those properties. So, here we are going to talk on solid at the first. Solid means you know stone, apple, pencil, plants, like anything we can take as the solid. So, in a solid you know the shape stays the same, you know that. Then the mass also stays the same and volume stays the same. That is the particle's nature of a solid. In a particle, it is hard to break its nature. That means particles are tightly bound to each other, so it is not easy to break those particles. Then about liquid. In the liquid, mass stays the same, volume stays the same and shape may be changed. So, this is the particle arrangement of a liquid. Here you can see liquids can be mixed together because of their particles nature, and the shape of a liquid can be changes. It changes up to the according to the container shape, and you can mix the things with liquid. You can prepare mixtures by using liquids like water. Then about the gas, here mass stays the same, volume changes, shape also changes like this. This is a air-filled balloons. This is the particle arrangement of a gas. In day-to-day life, we can see this status of matter in various types. Try to find solid, liquid and gases and their properties at our environment. When considering the water, the solid form of the water is the ice like this. Then the liquid form, that is our drinking water. Then gaseous form of the water may be water vapor or clouds like this. So, that is how our nature built up. Okay, now we are going to talk about organization of particles in a solid. In this picture, you can see there are particles. Those particles are the solid particles. As we talked in our previous examples, you can remember the arrangement type. Let us see what are the properties in this manner. Here particles are orderly arranged. You can see they have a nice order, like you all are sitting in your classroom, they have a specific order, right. Then the next one is these particles are strongly bound to each other. That is why they can't move here and there, they just do the vibration while at they are the same position. So, particles do not move relative to one another, but can vibrate in the same position as we talked. Then space among the particle is less. You can see the yellow color area is the spaces, this space amount is less in these solids. Next, we can talk about the organization of particles in a liquid. See this diagram, this is the particles arrangement in a liquid. Here particles are not orderly arranged. You saw it in previous video also, particles can move here and there. Next, though the particles are close to one another, the binding forces are not as strong as in a solid. Then, the particles can move within the liquid. Then, space among the particles is less but higher than that of a solid. So, those are the organization particles in a liquid. Now, we can talk about the last one, that is the organization level of a gas. Here you can see particles are not orderly arranged. Then the binding forces among the particles are very weak. Then particles move freely and randomly. So, at last much space is left among the particles. This is related to the gas. Then we can talk about some properties. Actually, we are going to talk about 4 properties here. We are going to compare 4 properties in solid, liquid and gases, right. Shall we take the property, the first one, shape, right. In a solid, it is said it has a definite shape. What do you mean by a definite shape? You know, that means the shape cannot be changed easily. Then in a liquid, you can see no definite shape. That means in a liquid, they haven't any specific or definite shapes. They can change their shape according to the container. You know that when you transfer liquid to one container to another one, it changes up to that manner. So, at last the gas has no definite shape, you know that. So, that is about the shape. Shall we talk about the next one, that is volume. Here in the volume, solid has a fixed volume. Then liquid also has a fixed volume, and but in a liquid it has no fixed volume. So, that is about the property volume. Then the next one, here we are going to talk about the density. Density means, you know, it is somewhat it means by a hard property. We are talking about the hardness of something. So, in a solid has a high density, you know that solid has the highest density. Then the liquid has a somewhat higher density, but it is somewhat lower than a solid, but still it has a high density. Then at last gas, you know gas density is very low. Then last property we are going to talk about the compressibility. What is this compressibility? If I will tell you example for this, here can you see this is a syringe. You can fill the syringe with gas like this. Now you know inside this syringe there is a gas. You can close at the other end and you can use this piston and you can press this like this. Then you know the air inside the piston is get compressed. So, that is what we call the compressibility. So, do you know here in this case the solid cannot be compressed, you know that solid can't be compressed like that. Then the liquid also cannot be compressed like that, but in the case of gas you saw we can compress a gas. So, we talk those 4 properties like that. Then we are going to talk about another topic, that is the uses of solids, or solids are used for various purposes depending on their properties. We are going to talk about that. Here as the example, parts of machinery, you know so many machines are made out of combination of variety of solids. Because of their less compressibility and hardness, high density like properties, they used for machinery purposes. Then the second one is parts of vehicles. Here you know almost all the parts in a vehicle made out of solids. that is also because high density, less compressibility like things. Then at last for building materials like this, you know, so many building materials like this are made out of solid matter. Then we are going to talk about the next one, liquids, about the liquids. You know, liquids are used for various purposes. As example, you can tell the mercury thermometer. You know the mercury thermometer. Here in mercury thermometer, mercury is used as a liquid, but there are some, you know, that alcohol thermometers also. Then hydraulic jack. Hydraulic jack, you know, that is the instrument we use to lift heavy vehicles. Here in this hydraulic jack they use liquids. Then as a medium of transport we use the water like medium, but do not forget in this case we can talk some more further like this. You know, in our body or in a plant body there is a watery medium inside us. So, it helps to transport materials. So, it is also we can take as a medium of transport, right. Then gases are used for various purposes like this. First one, you can see the inflating tires. In this case, normal air or nitrogen gas can be used. Then the second one, in pressure cookers. You know, pressure cooker is very useful instrument. Generated pressure inside the pressure cooker is used to cook our food very quickly. Then hydrogen balloons. Then at last in liquid petroleum gas or the LP gas, you know, it is a gas. Now you know the gas has high compressibility. Because of that high compressibility, they can compress and fill it up to the cylinders. Ultimately they will end up with the liquid nature, but it is the LP gas. Now you know all the uses of those three properties. Now we are going to talk about another new topic, that is pure and non-pure substances, right. Shall we see what are those pure and non-pure substances, right. Here in this table, can you see you have been given two substances. First one pure water, second one drinking water. In the second column, you can see pure water contain only one component, that is water. You can see that. So, in the third column we can put a tick like this. I think you can understand it, only one component. But in drinking water, think drinking water means it contains water, sometimes gases, some salts, like so many things. So, we can tick this column like this. So, here can you see another two words? In the previous column, it is indicated as pure. So, why is pure? That means if only one component is there, we can consider them as a pure component. That is why pure water is considered as a pure one. So, in the second case, non-pure means if more than one components are there, we can take them as non-pure components. Shall we take another example? Here the second example, you can see silver and copper. Silver, when we take the silver, it contains component as only silver. So, we can tell it is one component and it is a pure one. Then in the second case copper, if copper contain only one component, that means like this. So, it is another pure component. One more example for you. This is the substance you can see there are two substances in the first column, salt and salt solution. What is the difference between salt and salt solution? Actually, salt means salt is the pure salt. Then the salt solution means if you can dissolve some salt in water, you can make salt solution. So, let us see in a salt the component, only one component. So, we can say it is a pure one. In the second case, in a salt solution, here there are two components. So, we can say it is a non-pure component. Now, you know difference between pure and non-pure components. Here you can see again the pure components means matter that contain only one component, and second thing, non-pure substances mean matter that contains two or more components. Then when talking about the pure substances, you have to know another thing, that is based on the nature of those pure substances, we can classify them as to two. That is, you can see it in the blue color at last, elements and compounds. So, now you have to learn what are the elements and what are the compounds. Let us see. Here in your textbook, you have been given example. Actually, there are 8 examples in your textbook for the elements like this: sulfur, chlorine gas, iron, copper, carbon, mercury, aluminium and zinc. Let us see what are those compounds in a closer manner. Here you can see the sulfur. It is a yellow color substance, you can see. So, it is we consider as a element. Element means now you know it is a pure substance. You can see the nature of sulfur here. Then chlorine gas. Here you can see chlorine gas plant. Chlorine gas is another element. Chlorine can persist as chlorine gas. Here the iron, another element. Iron can be used in various ways. In laboratory purposes, we use some iron dust like this for various practicals. The other thing is that iron dust or iron particles attract to magnets. So, we can do various experiments in our laboratory using that iron dust. So, iron is another element. Then the copper, copper is another important element. Copper is widely used in connecting wires like thing. You can see the color of copper like this. Then carbon. Actually, have you known about this thing that carbon can be exist in various types, that may be sometimes as charcoal or coke or diamond. Those are variety forms of carbon. Then the mercury. Mercury is a liquid but a metal. So, here we learn it under the element. It is a pure element, right. So, mercury can be used in producing some bulbs like thing, then to fill thermometers like thing. Those are the purposes of mercury. Under the heavy metal, we learned that it is a heavy metal. Then the aluminium. Aluminium can be used to various purposes, kitchen utensils, sometimes we use to make that building materials like thing. So, aluminium is another element you have to learn. Then at last the zinc. You know, zinc is another metal and it is used, I think you have heard about galvanizing process. In galvanizing we use the zinc and we can use zinc for our laboratory purposes for various practicals. So, those are the elements you have to learn in this lesson. Keep in your mind, go to the definition. Elements means cannot be further divided by physical or chemical methods. So, those are the things you have to learn under the elements. Okay. Let us talk about the compounds next. Do you know compounds are homogeneous and pure substances, right? That may be 2 or more elements within a compound. You have been given several examples. This is from your textbook. You can see carbon dioxide, copper sulfate, sodium chloride, then calcium carbonate, sodium hydroxide, glucose, iron sulfides like thing. Do you know, when considering iron sulfide like thing, actually it is a compound. It is a pure compound, but it is made out of combining 2 elements, that is iron and sulfur. Let us see how to produce that. Here you can see they have taken iron, this is the iron dust, then the sulfur. They are going to mix them. Now you know they are mixing 2 elements, 2 pure elements, iron and sulfur. You know, magnet still can attract the iron, that means they haven't mixed chemically, only physically. So, here they are going to heat that mixture. Here you can see some chemical changes are happening. That means iron and sulfur get connected to form a new compound. That is what we call the iron sulfide. So, finally, they took that tube, it was a boiling tube. It is hard to remove that compound, that is why they break that tube. Then you can see that iron sulfide. See, at the mixture of iron and sulfur, here the compound, you can see the difference. Now, there is no magnetic property in the compound. So, it is a complete different compound. So, that is how you learn compounds in this lesson. Then, you have been given an example for a compound, that is copper sulfate. Now, you have to learn what are the elements in that compound. In previous video you saw iron sulfide contains some elements, likewise here the copper sulfate. You have been copper sulfate, then you have to tell what are the elements in that copper sulfate. So, what will be the elements? Let us see. The first one should be the copper, you know that. Then from the sulfate it will get sulfur and then next oxygen. So, those are the 3 elements that contain in a copper sulfate. So, like that in a sodium chloride it contains sodium and chlorine elements. Then sodium hydroxide, in sodium hydroxide sodium, hydrogen and oxygen. At last calcium carbonate. In calcium carbonate, calcium, carbon and oxygen. Okay, that is the end of part 1 of your lesson. Today we learned so many things. Can you remember at the beginning we talked about matter. Then we talked about, you can remember, we talked about energy. So, you learn differences between matter and energy. Then after that we talked about the discontinuous nature. Can you remember? We did so many practicals. At the first we did the practicals to show discontinuous nature of a solid. Can you see now our chalk is fully colored with that ink because of that discontinuous nature. Then at the second we did this for discontinuous nature of a liquid. Now you can see the color is distributed throughout the beaker because of discontinuous nature of that water. At last you can remember we talked about this, about the nitrogen dioxide gas. So, those are the practicals we talked. We did so many practicals today. Then we talked about pure and non-pure substances. You know how to differentiate pure and non-pure substances. Then we talked about elements and compounds. So, those are the summary of our lesson today. So, this is the end of part 1 of your lesson number 4, that is properties of matter. The rest of the lesson to be continued as a part 2 in another day. So, thank you very much for being with us and have a nice day and hope you stay safe. Goodbye all of you.